Welcome back to NCRT class 9th chapter number 8 motion. Children, in the previous class we studied about what is the differences between what are the differences between speed and velocity we came to know, along with the average speed and the average velocity. So dear children, in today's class we will discuss about one more important quantity of physics, which is called acceleration. Rate of change of velocity is nothing but here acceleration. So what we are going to discuss, children, in today's class we are discussing with acceleration concept. It is also called as a what? Rate of change of velocity. Isn't it? So what is the definition of this acceleration means what? Let us imagine, children, when a car or any object is moving means its velocity increases, isn't it, children? Then it is said to be a what? It is moving with some acceleration. Understanding my point, children? When the velocity increases means then it is said to be accelerating. You have to remember that whenever velocity increases means that is called as a word here acceleration is obtained in that. Means acceleration, it means, for example, if a car starts from rest, it means that initially its velocity will be at a zero level, isn't it? So if it moves means the velocity, if it attains a steady rate or uniform rate, let us say if it that is in 5 seconds it has reached 40 meters, isn't it, children? Or 40 kilometers it has reached. So here this is nothing but a 40 minus 0 is the velocity got increased. It means that final velocity to initial velocity. The difference of these two will give us a acceleration here. So let us take the definition first here. A body is said to be accelerated if there is a rate of change of velocity with according to what? With time. Then it is said to be a what? That object is in a acceleration. So in the expression form we will write, children, for acceleration always small letter you have to use. So acceleration is nothing but a rate of change of velocity. Divided by time taken. Isn't it, children? The definition what it says, an object is, that is acceleration is nothing but a rate of change of velocity with time taken or with the respected time is called as the acceleration. So that is, if a car, example, let us take a car, children. In 5 seconds it has reached, that is its velocity got 10 meter per second. It means that here in 1 second it completes how much? That is 5 1 ja 5 2 ja. Here for 1 second it is covering 2 meter per second. 2 meter per second is the acceleration here, isn't it? The rate of change of velocity is here what? 2 meter per second. So acceleration is nothing but a rate of change of velocity with time taken. So this can be written as a acceleration is equals to change in velocity, children. That is here it can be taken as a change in velocity. Change in velocity divided by time. You know children, this change in velocity can be written as the difference of final velocity minus initial velocity. It means that here, that is difference of final velocity minus initial velocity. And this can be written as a change in velocity, final velocity minus initial velocity. Here we can write final velocity as a v minus initial velocity as a u. Understanding children? The terms v and u represent v means final velocity, u means initial velocity. So now we can write this change in a velocity is nothing but a v minus u. Isn't it children? So now in this formula we can write acceleration means v minus u divided by time. What is the time children? Always it is represented with the small t. Isn't it? And here the acceleration letter is always expressed with small a. So small a is equals to v minus u divided by t is the formula for a acceleration. Is it understand children? What is the expression or a formula for acceleration? That is the difference of or change in velocity to the time taken. It can be written as a difference of final velocity and initial velocity to the time taken will give us a acceleration. Then what is the SI unit of this acceleration? We know that this acceleration is nothing but a change in a velocity. We already learned that velocity unit is what? Meter per second. So the SI unit of is a is equals to meter per second. This how comes? Because velocity unit divided by time. What is the time for unit for time? That is always expressed in seconds. So meter per, if this second goes up means second square. So the what is the unit children? A is equals to meter per second square. The SI unit of acceleration is always 1 meter per second square or meter per second into per second you can say. It's better children, you can say easily, that is meter per second square. Got it children? Is it the concept is clear? Acceleration means rate of change of velocity to the time taken. So this can be expressed using the formula A is equals to v minus t divided by t, and the SI unit what? Meter per second square. And this is also known as a accelerated motion children. What we call? This can be also called as a accelerated motion. And if an object is moving means you have to take always the acceleration positive. If the velocity is, for example, if the object is moving in the direction of a velocity means then you have to take a positive acceleration. Suppose the object is moving opposite to the direction of the velocity means then you have to take a negative acceleration. In general children, this negative acceleration is also called as a retardation or deceleration or negative acceleration. We have a different terms but the meaning is same. Negative acceleration means here if an object moves opposite to the direction of the velocity then you have to take a negative value, acceleration value. Is it concepts are clear children? Yes. What so we have learned children? Acceleration definition, rate of change of velocity to the time taken, and its formula can be obtained with the change in velocity is nothing but a v minus u. Here v means final velocity, u means initial velocity, and the formula for acceleration is what? V minus u divided by t. and the SI unit is what? Meter per second square. And this A is found positive for if an object moves in the direction of a velocity, and A can be taken as a negative if it is in the opposite direction. Is it clear, children? Okay, now we will discuss uniform acceleration and a non-uniform acceleration. Children, after learning acceleration definition, now we will discuss uniform acceleration and a non-uniform acceleration. Uniform acceleration and non-uniform acceleration, children. Non-uniform acceleration. So what is mean by this uniform acceleration? Let us imagine, children, if an object is moving along a straight line, the velocity of that object may increase or decrease by equal amounts in equal interval of a time. Then it is called as a what? Uniform acceleration. For example, if that is a freely rolling object on an inclined plane, isn't it, children? That can be called as a what? Uniform acceleration. Or freely falling object, it is also what? Uniform acceleration. Isn't it, children? Now we'll write definition. That is, if an object travels on a straight line, if velocity of that object increases or decreases by equal amounts in equal interval of time. Then it is called as a uniform acceleration. Example, children, freely falling object, isn't it? Then object rolling on an object on an inclined plane, etc. We can take under uniform acceleration, isn't it, children? Now, then what is the meaning of a non-uniform acceleration? If the velocity increases by unequal amount in equal intervals of a time, then it is called as a non-uniform acceleration. That is, if the velocity of an object increases unequal amounts, increases by unequal amount in equal interval of time, in equal interval of time, then it is said to be what? Moving in a non-uniform acceleration. It means that, children, for example, a car, let us take a car, children. If it is moving in a crowded area, its speed sometimes need to be increased and the speed need to decrease. If the road is straight, means it can move fast. The velocity is what? Moving at a steady rate, means uniform. But the same car, if it travels in a crowded area, what happens? At certain distances, the area might be with a less crowd. At the time, he will move fast. If it contains traffic or if the area is filled with the crowd, means he need to go slowly. Means here unequal amount, if the velocity of the object increases by unequal amount in equal interval of a time, then it is called as a non-uniform acceleration, isn't it? So example we can take, that is a car traveling in a crowded area, isn't it? It comes one non-uniform acceleration. Is it clear, children? I hope these all the important topics are clear to you. Children, it is very important to learn the definitions of these terms very first. Then only we can solve the problems at a easy method, isn't it, children? So I request you all, please learn these definitions thoroughly. Then only you will feel that easy while solving the problems. Children, now we will solve a numericals based upon these topics what we have up to learn. Here the first question comes, an object travels 16 meter in 4 seconds. How much meter, children? It is covering 16 meters in 4 seconds. Means the time has given and the distance has given. And then another it will cover somewhat distance. ಕಪ್ಪಲ್ ಕೊಡಿತೀನಿ ನೋಡಿ, ಬಾ ಮಿಷನ್ ಕೊಡ್ಬೇಕು. Children, now we will solve numericals based on all these topics what we have learnt up to now. And here our first question comes, that is, an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. So calculate or what is the average speed of the object is our question. Clearly they mentioned that, children, here it is covering certain distances at particular this time and another distance at this time, isn't it, children? So what is the formula we need to use to calculate average speed, children? Yes, very good. Average speed is equals to total distance travelled divided by total time taken. So using that we need to solve its what? Average speed. Before doing that, first we need to know total distance. Here they have mentioned this much distance it has travelled and another distance also it has travelled. So first our step is one to calculate total distance and total time taken. Total distance is how much, children? That is 16 meter plus 16 meter, which is nothing but a how much, children? 32 meter is the total distance. And similarly the total time taken we need to calculate. Total time taken is equals to first one 4 seconds. It will take to cover 16 meter in 4 seconds and the next another 60 meter in 2 seconds. So what is the total? 4 plus 2? 6 seconds is the total time taken. Now using the formula, children, what is that? Average speed is equals to total distance travelled divided by total time taken. So what is the average speed? In short, you can write average it as a AVG, isn't it, children? Average speed is equals to total distance is 32 meter divided by total time 6 seconds, isn't it, children? So here 6 5s are 32 is left, then 6 3s are 18, again 2 left, once again 3s are, like this it will continues. So what is the unit of speed? Meter per second. Therefore we can say the average speed is how much, children? Average speed is equals to 5.33 meter per second. This is our answer. Is it clear, children? Understood each and every concept? Okay, now we will solve one more problem. We will solve one more problem which is from your science textbook, that is page number 100. In text questions you can say, that is in that page number 100, question number 2. And the question here is that a farmer moves along the boundary of a square field. Which field, children? He is making a round, that is in the square field, which have a side 10 meter in 40 seconds. What will be the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So children, let us assume a farmer is making movement from this point to here. Let us name it as a B, and then he goes to this this point C, and he goes to D, and from D to he'll move to same, that is initial position A. Like this, a farmer is moving across his boundary of a square field. What is this distance, children? 10 meter. He'll cover in 40 seconds. Isn't it? This side is 10 meter and this side is also 10 meter, and here also and here also. With this, we need to calculate the magnitude of the displacement, children, at the end of 2 minutes 20 seconds. It is very clear, children. The timing they has given as time, that is 2 minutes 20 seconds. So first we'll convert this into seconds, because the unit of a time is what? Seconds, no? So 2 into 60. 1 minute contains 60 seconds. So shall we write in this way? Okay. Now another 26 will add. So what is the total, children? 120 plus 20, which is nothing but a 140. So our timing is what? 140 seconds. Suppose that is in 40 seconds he is making a one round, children. Isn't it? In 40 seconds he is completing, means this farmer is moving from point A to B, B to C, and C to D, and then D to E. This is what? One complete rotation he is making in how much time? In 40 seconds. Then in 140 seconds, how many rounds he will make is our question. Isn't it, children? Let us take, for example, to cover this square field, he is taking what? 40 seconds of a time. And next 40 seconds, he'll cover the second round. Isn't it, children? This might be 80 seconds. Then for the next another 40 seconds, means for 120 seconds, he'll complete 3 rounds. But our how many seconds? 140 seconds is there. Isn't it? So let us add 20 seconds more. He may cover exactly half of the complete square field. Isn't it, children? So at 140 seconds, the position of the farmer will be in this way. So now what we will do? Half of this square field will take, children. Because in 40 seconds he'll completing one round. Isn't it? This he'll make one round. Then in another 80 seconds he'll make 2 rounds. Then in 120 seconds he'll complete third round. And in 140 seconds he'll complete half of this. Isn't it? This is what he'll position. Means in the third and half minute he will be moving from A to B and B to C and C to A. Is it his initial position? Means he is completing how many rounds, children? He completes 3.5 rounds. He will complete in 140 seconds. And here, this is a right angle triangle, children. A, B, C looks like a right angle triangle. So the hypotenuse, how we will take, children? That is AC square. This line AC square, because this is 3.5 rounds he'll make in 140 seconds. Isn't it, children? AC square is equals to this side. AB square plus BC square. Isn't it, children? All the sides are equal in length. This side and also this side 10 meter. Isn't it, children? So now AC square is equals to, what is the value of AB square, children? How much distance is there? 10 meter. Means 10 square. BC is also 10. 10 square we can write. 10 square is nothing but a, children, 100 plus 100. Isn't it? The hypotenuse AC square is equals to 100 plus 100, which is nothing but a 200. This can be written as now, that is AC is equals to square root of 200. Isn't it, children? AC can be written as a, this square power goes to here means it can be written as a square root of 200. Find out the square root of 200. First let us take 200 is that is square root. It is very difficult to calculate now, but you can take the nearest value directly, children. 10 means very far away. 10 tens are 100. Then 11 11s are not coming. 121 it is also far away. Then 13 13s are, it is very far. And next, what is that? 14 14s are, it may, if we may get, that is 14 into 14. Then 4 19. 194 is very near to a 200. So we can take the square root as a 14. Then how much left? 6 has left. You can keep point here. Then 1. Then next 4 then 3 So our answer is what, children? 14.143 meter is the distance he will cover in a 3.5 second. That is in that rounds he will make a this much amount of a displacement. Is it clear, children? So the magnitude of the displacement at 2 minutes 20 seconds he will make 14.143 meter. Children, once then I'll explain you. The question is that a farmer is going to make a round in his square field, so that the length of the field is what? One side 10 meter and timing is what? 10 seconds. So in 2 minutes 20 seconds, what will be its magnitude of a displacement? First, let us convert this timing in seconds. We will get a timing as a 140 seconds. In 40 seconds he is making a one round, means in 140 seconds how many rounds he will make? That is, you can make here, that is 1 means you can make 1 by 40 into 140, isn't it? You will get a 3.5 rounds he will complete in 140 seconds. And since this looks like a right angle triangle, that is ABC, and here AC is the hypotenuse, so we can take AC square is equals to AB square plus BC square. AB value is how much? 10, and similarly BC also 10. That is square of a 10 is what? 100 plus 100, 200 you will get. Square root of a 200 is what? 15.143 meter is our answer. Is it clear, children? In today's class, what all the things we learn? Acceleration means what? It means nothing but a rate of change of velocity with the time, and when it has to be taken positive and a negative. And uniform acceleration means what? And a non-uniform acceleration means what we learn. And also the SI unit of acceleration we learn.